Okay, so what caught your eye on that infinite series?
So they were just talking about, I think the first one they introduced was the idea of 0.99999 and looking at that as being an infinite series, or at least infinitely repeating decimal. So 0.999, or I guess you could just say 0.9 repeating.
Uh-huh.
And does this equal 1?
Yeah, put a question mark over that equals. So, does this equal 1? Okay, but before you even go into it, what do you think?
I would say, like, as a person who had never seen this before, I would say no, because, like, just because of this, the 1's digit here is equal to 0, and then anything that has this 0 here is going to be less than 1.
Okay.
It should be less than 1.
Is that what you think, or is that...
That's what I would think if I hadn't seen this before.
Oh, if you hadn't seen it before, you would think they weren't the same. I see, okay. But you have seen it before. So what do you think?
I'd say it is equal to 1.
Okay, you think it is equal to 1. Okay.
And then, so the first reason, the reason that the book gave, so the most simple reason, is that this is the decimal expansion for 9/9, which is equal to 1.
Okay.
Because 1/9 is 0.11111.
Yep.
Repeating. And so the book said that we know that a third is equal to 0.3333
Right.
repeating, and we can multiply that by 3 and get 0.999.
Okay. Well, what do you think of this argument, generally?
That seems like a pretty solid argument. I mean, we know
Okay.
the decimal expansion of 1/3, and we know that a third times 3 is 1.
All right, so nobody's bothered by a third being this. I
Yeah.
guess is the argument. So you shouldn't be bothered by 0.999 equal. Okay, that's an interesting argument. All right, what else?
And then the way to disprove this is to look at some other infinite series and use sort of the same logic and then see if something breaks.
All right, do you have one that comes to mind?
So
We have 3 minutes of recording time left.
So I'll just go over one of the examples. So look at the infinite series 1 plus 2 plus 4 plus 8. And so every term we're going to multiply the previous term by 2. And then that's the next term. And we want to know, what does this equal? So using the same logic as Zeno's paradox used, we can multiply all the terms by 2 after setting this to x, so we get 2 plus 4 plus 8 plus 16 and so on, and this equals 2x.
Mm-hmm.
And then again, these terms line up, and so we can subtract away 2x and be left with 1, and that's the only term, because every term in 2x matches a term in x.
All right.
But this time we're left with minus x, and so we get that this series is equal to -1.
All right, so 1 plus 2 plus 4 plus 8 plus always multiplying 2 all the way out forever equals -1. Mm-hmm. Do you believe this?
No, because, I mean, just a few projects ago we looked at the Koch curve and that infinite series, and we said because you're adding on more each time. You're adding the amount you're adding to each term to get the next term increases. You go from 1 to 2 to 4, and this should go to infinity. Because of that, it should diverge.
Well, maybe we made a mistake, and the perimeter of the Koch curve is actually -1.
It's possible.
I guess. All right. So, but this looks like in your mind this should go to infinity, not to -1. Okay.
And you could use this argument sort of.
But it does look a lot like the argument you used for the 1 plus a half, or a half plus a fourth series.
Yeah.
So why do you think it worked there? Or why do you think, not that it worked, that it seemed to make sense there?
Well, we didn't get any outlandish results like this, because
True.
It seemed plausible that a half plus a fourth plus an eighth converged to something, because the amount you're adding every time, each term gets smaller as you go on.
Yeah.
But each term gets larger every time. It should go to infinity, but it doesn't.
Well, it certainly does go to infinity.
Or, I guess,
It keeps getting larger anyway.
Yeah.
But this
Somehow
this arithmetic says that it equals minus
equals
1.
minus 1.
So yeah, that's a surprise. So what do you think? Do you believe that the series equals minus 1?
No, I don't.
No, you don't.
Just
Okay.
doesn't make
But you
much
believe
sense.
you believe 0.9999 does equal
Yeah.
1, and
I think so.
half plus a fourth plus an eighth is 1. Okay, cool. Yeah, it's an interesting book and some really interesting ideas.
Yeah.
All right, high five. Great job, man.